welcome to Excellence Academy. So we're actually looking at the basic rules for naming any organic compound. And in the last class, we looked at 3 of the basic rules for naming organic compound. We said the first rule is to get the longest continuous carbon chain and to name it as your root hydrocarbon. The second rule was to get the functional group or identify the functional group. If it's single bond, it's an alkane. For double bond, alkene. For triple bond, alkyne, and etc. The third rule was to do your numbering such that you have the least number being attached to the substituent. So these were the 3 rules we considered in the previous class. For today, we're looking at 3 more rules that guides our ability to name organic compounds, which is the 4th rule. The 4th rule is this: if the substituent is present more than one time in the organic compound, then the substituent must be represented using a prefix. The prefix is di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and etc. So if I have more than one substituent, I'll represent it using di for 2, tri for 3, tetra for 4, penta for 5, hexa for 6, and etc. We'll take an example and explain this fact. For instance, let's say I have a compound such as this. Let's say I have a compound that looks like this one here. So I'll combine with 1, 2, 3, and 4, and let's see how we can possibly name this compound. Alright, so the first case here would be to identify the longest continuous carbon chain. Obviously, from this I can say 1, 2, 3, 4, 5. So I'm having 5 continuous carbon chain, and we said 5 is simply a pent. Next up, I'll look out for the functional group. If I look, that's from my root 2, functional group. From this, I can see just single bond throughout this compound. Hence, the functional group is single bond, which is an alkane. The third group will be to get my substituents. My substituents in this case are bromine, this one here, and this, bromine. But what do you observe here? Bromine occurs more than once. So there are 2 bromine atoms in this compound. Hence, I'll take the third rule, which has to do with numbering. I'll number this compound from left to right, lower numbering 1, 2, 3, 4, and 5. I also number this upper numbering from right to left, gives you 1, 2, 3, 4, and 5. So I have this. So I'll compare between the lower numbering and upper numbering. I'll look for the one that gives me the least possible number. If I go with lower numbering here, this first bromine here occurs at carbon 2, and the second bromine here occurs at carbon 3, using my lower numbering. So hence, from lower numbering, my bromine occurs at carbon 2 and carbon 3. If I go into upper numbering now, I can see bromine from here. This is 1, 2, 3. So hence, bromine from upper numbering occurs at carbon 3 and carbon 4. So from lower numbering, having 2 and 3 as the positions of bromine. From upper numbering, having 3 and 4 as the positions of bromine. We said the rule is that I'll take the least possible numbering. Between these two, my least is of course 2 and 3, which is this. So I'll go with 2 and 3, my lower numbering. Hence, I'll take off the upper numbering. So these ones are off. Take off the upper numbering and go with lower numbering. Alright, so next up, I will name this compound starting with the substituent. But before then, I'll have to show the position of the substituent in this compound. So since bromine occurs at position 2 and 3, this becomes 2, 3. Now, if you observe this, there are 2 bromine atoms, and we said if the substituent occurs more than once, we should use what there? Di. So since it's 2, I'm having di, so it becomes 2, 3, di of bromine, so it becomes bromo. Alright, so this is 2,3-dibromo, and then this compound was pent for 5 carbon, pent. Then next up, the functional group was alkane, becomes alkane. So this compound is named 2,3-dibromopentane. So this is how you name compounds involving multiple substituents. A second example, let's say I have this. If I have this, so I have this. My first task would be to balance up this. Don't forget this is 1. I'll need 2, 3, and 4 to balance up this compound. Alright, case 1, get the longest continuous carbon chain. Obviously, this is my longest continuous carbon chain. So it becomes 1, 2, 3, 4, 5, and 6. So I have this as my longest continuous carbon chain. This is 6 carbon atoms joined together. That's 6. Next up, that means these ones become my substituent. Of course, as earlier discussed, CH3 is a methyl. So I have methyl at 1, 2, and 3. I have 3 methyl substituents here. So root 3 now, or root 2, get your, okay, so I'm having 1, 2, 3, 4, 5, 6. 6, as we said, is a hex. Okay. Next up, get your functional group. For this, is a single bond that makes it an alkane. Number 3, number my hydrocarbon to give the least possible number to the substituent. So it becomes 1, 2, 3, 4, 5, 6. Do upper number. I'm having 1, 2, 3, 4, 5, and 6. Alright, so if I go with lower number now, my substituent occurs at, I have 3 substituents here, this, and they are the same thing. They are all methyl. So if I go with lower number, I can see 2 and 3. So this particular methyl occurs at carbon 2, while these 2 other methyls occur at carbon 3. That's using my lower numbering. So then the position becomes 2, 3 from lower numbering. If I go with upper numbering, I'm having 4, having these 2 here. So carbon 4 from upper numbering contains these 2 methyl group, and then carbon 5 contains this one here. Of course, my least possible number is 2, 3 as compared to 4, 5. Hence, I will eliminate the upper numbering and just go with the lower numbering. Alright, so if I go with this now, that means my number becomes 2, 3, but at carbon 3, there are 2 methyl group. So it becomes 2, 3, 3. Alright, so 2 for this one here. And I have 3 for this one here. And also 3 for this one here. So I'm having this. So it becomes 2, 3, 3, my number. So this is now called 2, 3, 3. In this case, I have 3 substituents. For 3, we said we use tri. So it becomes hyphen tri. Tri of what is the substituent here? The substituent here is methyl, so it becomes tri-methyl. Next up, my longest continuous carbon chain, I had 6. 6 is hex, becomes hex. From functional group is an ane or an alkane, becomes hexane. So this compound is 2,3,3-tri-methyl-hexane. So this is how you number, or this is how you name compounds like this, having multiple substituents, right? Use 2 for that and what have you. So that's the 4th rule. The 5th rule is this: if there is more than one type of substituent in a particular molecule, then the substituents are named according to alphabetical order. So if I have more than one type of substituents, I will name them according to alphabetical order. Of course, from the English alphabet, obviously. Let's take an example of what we mean. So let's say I have this. Let's say I have this, for instance. I'm having this, this. Okay. So I have a compound of this nature, and I'm to name this compound. So how do I name this? Alright, case 1. Get your longest continuous carbon chain. I have 1, 2, 3, 4. 4, as you have it, is a boot. Number 2, look out for your functional group. The functional group here obviously is a single bond, so it becomes an alkane. Number 3, get substituents. I have 3 substituents here: bromine, fluorine, and chlorine. So in cases like this, now what do? We are taking them. Okay, first of all, let's do the numbering. Lower numbering left to right, upper numbering right to left. So I'm having 1, 2, 3, 4. This way now. 1, 2, 3, 4. So I'm having bromine, fluorine, and chlorine in this compound. The question now is this: which will I consider first? We said if I look at my substituent, I have bromine there, I have fluorine there, I have chlorine. So which do I consider first? We said take them according to alphabetical order. From alphabetical order, the first one will be for bromine. From alphabetical order, the next will be chlorine, that's C. From alphabetical order, the next has to be fluorine, that's F. So I have this as my substituents from alphabetical order, or the arrangement of my substituents from alphabetical order. At this point now, I'll now choose the numbering that favors bromine first, since I'm going with alphabetical order. So which of these numberings favors bromine, or takes or has the least possible number for bromine? If I go with lower numbering now, I can see 1 attached to the carbon bearing bromine. If I go with upper numbering, I can see 4 attached to the carbon bearing bromine. So between 1 and 4, the least number there is 1. So I'll go with what there? The lower numbering. Hence, I will eliminate the upper numbering. So this one is off. Alright. So the name becomes, so we take bromine first, take chlorine next, and then fluorine. It becomes 1 bromo, because bromine is attached to carbon 1, so it's called 1 bromo. Next up, chlorine to carbon 3 becomes 3 chloro. So from B to C, from C to F. Fluorine is at carbon 2, so it becomes 2 fluoro. So this is 1 bromo, bromine to carbon 1. From alphabetical order, chlorine next, C, so it becomes 3 chloro, and then 2 fluoro, 1, 2, 3, 4. That's boot, so it becomes boot. I'm having boot. Finally, it's an alkane, so I have butane. So this compound is called 1 bromo, 3 chloro, 2 fluorobutane. That's the name of this compound. Also, if I have a combination of different types of substituents, example having organic substituents and inorganic substituents. Organic substituents are your alkyl group, that's the methyl, ethyl, propyl, and etc. While your inorganic substituent becomes your halogens, such as bromine, chlorine, and what have you. So in the case where I have both organic and inorganic substituents in a compound, I'll take the inorganic substituent first before the organic substituent. We'll take an example and we'll see what we mean. So let's say I have a compound having a mixture or perhaps a combination of organic and inorganic substituents. So let's say I have this compound such as this. Okay, so I have this one here. I have this here. I have this one here. I'm trying to balance up this compound and see what I can get. I have this one here. I have this pitch here. have F here. This K, here like D. Alright. This, and finally this. Alright, so I'm having to name this compound. How do I name this? My first task would be to identify the longest continuous carbon chain. Obviously, for this now, my longest continuous carbon chain would be 1, 2, 3, 4, or let's go this way, 5, 6. 2 carbon here, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6, 7. So I have 7 here. So I'll take up this one here as my longest continuous carbon chain because it has 7 carbon atoms linked together. Of course, we said 7 is called what there? Hertz. Alright, that's case 1. Case 2, we get the functional group. The functional group here obviously is a single bond. I can see single bond throughout of this. So that means it's what there? And I'm K for a single bond. My third rule will be to do my numbering here. I'll take numbering as 1, 2, 3, 4, 5, 6, 7. Upper numbering 1, 2, 3, 4, 5, 6, 7. This becomes a case where I have both organic substituents such as methyl here and ethyl here combined with inorganic substituents such as bromine, fluorine, chlorine, iodine. So I'm having this case now. How do I name this? How do I name this compound here? The first case will be this. From this, we said when you're having your organic substituents and inorganic substituents, your priority is your inorganic substituents. That means your halogens. Alright, so if I go with the halogens first, I can see bromine here. Right. I can see, I'm trying to arrange them in alphabetical order. From B, I have C for chlorine. So I can see chlorine next. From C, obviously I should have F before I. So I can see fluorine and then iodine. Alright, so this becomes my alphabetical order arrangement of the substituents. So I'm starting with bromine here. Between lower numbering and upper numbering, which one gives you the least possible number to bromine? Obviously, it's my lower numbering because from lower numbering, I can see these 2 bromine as carbon 2 and 3 as opposed to upper numbering 5 and 6. So my lower numbering gives you the least possible number. Now let me clear something, please. It doesn't always mean that lower numbering will give you the least possible number. No, in some cases you can still have upper numbering as giving you the least possible number. So please be careful with it, please. Alright, so that means I'll discard the upper numbering. I'll discard this one here and go with just lower numbering. So if I go with lower numbering here, I'm going to take bromine first, chlorine, fluorine, and then iodine. Let's start with bromine. For bromine here, bromine is at position 2 and 3. So it becomes 2, 3, dibromo. It's a dibromo because I have 2 atoms of bromine. So I'm done with bromine there. Next up, take up chlorine. Chlorine is at position here, 3 and 6. So it becomes 3, 6, dichloro. Okay, I think I'm done with chlorine here. Next up, take out fluorine. Fluorine is at position 4. So it becomes 4 fluoro. I think that's all. Yep, I'm done with fluorine. Next up, pick up iodine. I can see iodine at position 6. So it gives you 6 iodo. So I'm done with iodine. Iodine is off. Next up, so I'm done with my inorganic substituents. Pick up organic substituents. My organic substituents here are methyl and ethyl. Some authors say when it comes to the organic substituents, you arrange them according to position. From position, I have 1 carbon, that's methyl, before 2 carbon, that's ethyl. So some say use position before, consider position, that's methyl before ethyl. Some say go with alphabetical order. If I go with alphabetical order, obviously I'll have ethyl, that's E, before methyl, that's M. So for this now, I'm choosing to go with alphabetical order to continue with the same line of thought as the inorganic substituents. That means I'm taking ethyl first before methyl. For ethyl, this is ethyl here. Ethyl is attached to carbon 4, so it gives you 4 ethyl. That means ethyl is at carbon 4. From here, I can see this one here, methyl at carbon 5. So it becomes 5 methyl. So having 5 methyl. Alright, so next up, I think I'm done with substituents now. So take the parent hydrocarbon. From parent hydrocarbon, we counted 7, and we said 7 is hept. It becomes hept. From substituent is an alkane, so ANE. I'm having heptane. So this is called 2,3-dibromo, 3,6-dichloro, 4-fluoro, 6-iodo, 4-ethyl, 5-methylpentane. Okay, so this is the name of this compound. We'll take one more example on this, and then we'll wrap it up with this particular room. So let's look at another case of this. Look at another case of this. Q. Okay, let me put this here. Right? Yeah. Alright, so let's name this compound. So let's say I'm asked to name this compound. What do? I'll get my longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Obviously that's not the longest. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's one here, 11. Okay, and then also this one here too, 11. Now I'll take this one here. So this becomes my longest continuous carbon chain from here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'll take this one here as my longest continuous carbon chain. Now, if I count it this way, this is 10, 11. This could have also been my longest continuous carbon chain. But the thing is this, it's easier I name it this way because this is actually more of like CH3 here. It's well, when I go this way or this way, they are both the same thing. Alright, so get smart this way. I'm having this this way. Okay, I'm having this one this way. Alright, so I'm having this as my longest continuous carbon chain. Next up, so if I count my longest continuous carbon chain, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, as we know it, is on deck. Next up, I'll look out for your, what do you call it? Functional group. The functional group here is a single bond. Single bond becomes an alkane. Okay. Next up, do my numbering. So lower numbering 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Upper numbering this way, I'm having 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So between the lower numbering and upper numbering, which do I take? If I look at my substituents here, let's start with, we said we consider inorganic substituents first before the organic substituents. So from inorganic substituents, I can see bromine, I can see chlorine, I can see fluorine, I can see iodine. So in alphabetical order, my bromine first. So I'll take bromine. This bromine is close to this point. This bromine is also close to this one, this end here. So which do I consider first? Is it this one here or this? Obviously, if I go with lower numbering here, I'm seeing bromine at carbon 1 from lower numbering. If I go with bromine here is, okay, before that, this bromine is carbon 1 from lower numbering and at carbon 11 from upper numbering. This bromine here is at carbon 2 from upper numbering, as you can see here, and carbon 10 from lower numbering, as you can see here. So 2, 10, 1, 11. My least possible number here is obviously 1. Alright, so that means I'll still go with what there? The lower numbering in this case. So that means I will eliminate the upper numbering and pick up lower numbering instead. So if I go with lower numbering here, I can see this at carbon, this is 1 here. So I can see bromine at, I can see how many bromine here. This is 1, this is 2, this is 3. So this is carbon 1, bromine carbon 1, bromine here carbon 3. The third bromine carbon 10. So it becomes 1, 3, and 10. So I'll call this 1, 3, 10. I have 3 atoms of bromine, so it becomes a tribromo. So 1, 3, 10, tribromo. I'm done with bromine. From alphabetical order, after we take C. So look at chlorine. Chlorine is any chlorine here? Okay, yeah. I can see 1 chlorine here. That's all. You can see this chlorine here at carbon 2. So it becomes 2 chloro. So chlorine is off. From chlorine, next up is fluorine. I can see fluorine at 1, 2, 3 positions. This fluorine is at carbon 3. This one is at carbon 4. This fluorine is at carbon 7. So it becomes 3, 4, and 7. So it becomes 3, 4, 7. I have 3 atoms of chlorine. So it becomes what there? A or 3 atoms of fluorine. Here, so it becomes trifluoro. Becomes trifluoro. So fluorine is off. And I can also see iodine too. Just how many iodine here? Just this one here. This is at carbon 8. So it becomes 8 iodo. Becomes 8 iodo. I think I'm done with my inorganic substituents. Look at organic substituents. So for organic substituent now, I can see methyl here. I can see methyl here. I can see ethyl here. I can see propyl here. Also this one, so this is actually ethyl in its structural form. C2, 1, 2, 3, 4, 5. C2H5. That's the same as this one here. So from alphabetical order now, I'll take ethyl before methyl and then propyl. That's E, M, and P from alphabetical order. So it becomes E, ethyl. Ethyl is at position, this one here is at 5. This one here is at 8. So it becomes 5, 8 diethyl. That's 2 of ethyl. Becomes 5, 8 diethyl. Okay, 5, 8 diethyl. What next? I'm done with ethyl. Go to methyl. Methyl is at position 2, 5. Is that all? Okay, there's 1 here. So 10. Becomes 2, 5, 10 for methyl. So it becomes 2, 5, 10. 2, 5, 10. I have 3 methyl atoms. So it becomes tri. That's 3 methyl I'm done with methyl. Look at propyl. I have just one propyl here at carbon 6. It gives you 6 propyl. I think I'm done with all my substituents. I'll now take my longest continuous carbon chain. We counted 11, which was on deck. So it becomes on deck. This on deck, that's 11 carbon atoms joined together. And from the functional group, it was a single bond, that's alkane. It becomes on decane. So this compound is named 1,3,10 tribromo 2-chloro 3,4,7 trifluoro 8-iodo 5,8-diethyl 2,5,10 trimethyl 6-propyl on decane. So this is how you name compounds of this nature involving organic and inorganic substituent. One final rule is this: if the organic compound is in ring form or ring structure, alright, use the term or use the prefix cyclo followed by the functional group. Example, cycloalkane and cycloalkene. That's cycloalkane for single bond, cycloalkene for double bond, cycloalkyne for triple bond, cycloalkanol for OH, and etc. We'll take an example on this or some examples on this and we'll wrap this up. Okay, so we said use cyclo for compounds involving ring forms. How does that work? Look at this. Take some few examples and wrap up this section. So let's say I have this 1, 2, and 3. I have this one here. This carbon is having 1, 2. Add 2 hydrogen to make it 4 and balance. This carbon is having 1, 2 bonds. Add 2 hydrogen to make it 4. This carbon is having 1, 2. Add 2 hydrogen to make it 4. So I'm going to name this compound here. Get my longest continuous carbon chain. This becomes 1, 2, 3. 3 we said is pro. Next up, look out for your functional group. It's a single bond, that's alkane. So this becomes a propane, but this is in a ring form on a cyclic path. So it's called, we said use the term cyclo. So it's called cyclopropane. Alright, so that's the name of this compound, cyclopropane. Take a second example. Let's say I have something of this nature. Perhaps I should add a substituent here to make it more interesting. Alright, okay, this one here. So this one is having 1, 2, 3, 4, it's balanced. This one has 1, 2, 3, 4, it's balanced, and etc. Alright, they have 1, 2, 3, 4. 4 there, or 4 carbon, is both. I can see single bond throughout this atom. Single bond is an alkane. I can see a bromine here. Alright, so I'll number this one here. Where do I start my numbering? It's best still if you start from this point here, that becomes 1. So call this 1, and then you can move whichever way you want to. Alright, so it becomes 1. So this is now called 1 bromo. Bromo, not just butane. Since the butane is in a cyclic form, it becomes cyclo and then put butane there. So this compound is called 1 bromo cyclobutane. One last example and we're done with this. Let's say I have this compound here. Okay, so I have this compound this way. Alright, so okay, so this one has 1, 2. I'll have H2 here to make it 4. This is 1, 2. I'll have H2 here to make it 4. This is 1, 2. I'll have H2 here to make it 4. Perhaps I want to add a substituent bromine here, and I put a H here. It becomes 1, 2, 3, 4. It's balanced. And you can simply say CHBr. It's correct. 1, 2. So 1, 2. Let me say I want to put a bromine here. Bromine here. Br and H. So I'm going to put a chlorine somewhere here, Cl, chlorine and hydrogen, or you can swap this, whichever one. 1, 2, put a H2 here, make it 4. 1, 2, put H2 there to make it 4. Alright, let's name this compound. Longest continuous carbon chain. 1, 2, 3, 4, 5, 6, 7, 8. 8, as we said, is an oct. Next up, this is single bond throughout, so it becomes an alkane. Single bond alkane. Next up, I'll look at my substituents. Obviously, for this now, my substituents are bromine and then chlorine. So it's better I start with the bromine. So which of the bromine do I start with? This one or this? Now, obviously, I'm having 2 bromine here. It's wise to start this way. If I start here, if I call here 1 now, I'll have to go this way. So I'll have 1, 2, 3, 4. Okay? So the numbering now is now 1, 2, dibromo and 4 chloro. Instead of going this way, now if I go this way, I may have 1, 2, 3, 4, 5, 6, 7, 8, and that's a very big number if you look at the substituents. If I start with this one here, I go 1, 2. Okay, it's still fine. It's still similar as 1, 2 here. But look at it, chlorine becomes 1, 2, 3, 4, 5, 6, 7. 7 to chlorine. So the least possible way of numbering this will be this way here. Alright, so I'm having 1, 2, dibromo. 1, 2, dibromo. Take chlorine. Chlorine is at position 4. Becomes 4 chloro. Okay. Take my longest continuous carbon chain is 8. That's an oct. So it becomes, okay, before that, it's in a ring form. So it becomes cyclo. So cyclo, 8 carbon atoms becomes oct. Functional group alkane becomes 8. So this is now 1, 2, dibromo, 4 chloro, cyclooctane. That's the name of this compound. So these are like my 6 rules of naming any organic compound. Right, so I hope you found this video helpful. Do want to like the video and also share to your friends, and make sure you subscribe to my channel.